In the last video, we learned about all the Stewart equations, we derived them, but there are a couple of things that I missed in mentioning in that video. So now I would be doing the same. Okay. So first of all, the point number one that you need to note is that all the Stewart equations, like let us say V is equal to U plus AT, uh, S is equal to UT plus half AT square, and the third equation is V square minus U square is equal to 2AS. These all equations, they look scalar, but they are not scalar because they are basically based on vectors. So these all are vector equations. So technically, the right way of writing them is this, because you are actually referring to the vectors. So this is a displacement vector, this is the velocity vector into time t. So if vector equation is given, like just try to imagine that you're doing vectors in your maths AAHL. Now you're talking with the terms of in the terms of I, J and K, and the vector is given. You can completely substitute the value as a vector and you can solve this equation. This is that kind of a big powerful equation, but we are usually uh, more comfortable with using scalar terminologies because the motion is not changing, motion is in the one direction only, and the acceleration is constant and the direction is not changing, so you cannot actually work with two or three directions there. So clearly, if you're using them in the scalar terms, even then it is correct, but actually they are the vector equations. Now in the case of vectors, the direction become very important. Now when the direction becomes important, so what we have to do is, for the horizontal direction we choose one direction to be positive and another direction to be negative. Similarly, in the case of vertical motion also, we would be taking one direction as positive and another direction as negative. Now, so point number one to be noted is that all these equations which look scalar are actually not scalar, but we have to work around only in the one direction, so it doesn't hardly matter. Now, here, but because they are vectors, we got to have a sign convention. For the horizontal direction, we would be having a sign convention. For the vertical, we would be having a sign convention. Although the sign convention can be chosen by you in whatever way you want to choose. If you want to say that the left direction will be chosen as positive, the right will be negative, it is your sweet will. If you say that the upper is negative and the downward is positive, it is your sweet will, because this sign convention can be chosen according to the case that you are actually dealing with. Okay, so these equations, sign conventions have to be there, and we would be substituting our value with sign convention in these formulas. So we would be looking forward to these kind of things in a next video. In our next video, we are going for the projectile motion, and at that time everything will be clear to you. Anyways, having said that, now we are moving into our next topic, which is the topic for this video particularly, and that is the graphs. The graphs for the Stewart equations, uniformly accelerated motion and others. So there are many graphs, many type of graphs I would say, and they are highly confusing, no doubt about that. But I am going to draw 9 graphs in front of you here. Those 9 graphs would be able to teach you majority of the things. Okay, now let us see. So this is the first graph. So all the graphs are connected with each other. So if you're drawing now, you have to draw all the graphs on the single page, the way I am doing. Like this. So all these 3 graphs, they are related with each other. Then this is the second case, and the 3 graphs are related with the same motion. Like this. Okay. Now, what are these graphs? This is displacement time. The top 3 are displacement time graph. The second one are the velocity time graph. And the last one is acceleration time graph. Yes. So there are 3 different motions that we are now going to deal. So in the first case, I'm going to draw a straight line here. So there are students, those who say that, sir, we know many things about the graph and we do not want to learn, fine, no problem, you can skip this video, but to the other students, please don't skip it. This is very important graph. Okay, very, very important video. So this is the graph in which I'm having a horizontal straight line. What does it mean? It means that the position of the body does not change with respect to time, which only means that it means that the body is at rest. So the body is at rest, and this will be the graph if the body is at rest. So what is the velocity time graph? Velocity is zero all the time, so there will be no graph for this. And because the velocity is constant and it is not changing its value, it was zero, it is zero, it only means that the acceleration also is zero in our first case. So these are the first kind of motion, like I just calling it rest. So at rest the velocity is zero, acceleration is zero. Fine. So now we're talking about the velocity time graph, and I'm going to make a straight line here. Now what does this mean? So this straight line means that the velocity does not change. Velocity does not change neither in the magnitude nor in the direction. It means I'm talking about the uniform motion. So I can just write it here as uniform motion. So this is the uniform motion. Now, if it is uniform motion and velocity does not change, it means that the acceleration will definitely be equal to zero, because the velocity is not changing. Now, if uniform motion is there, how do you think will be the graph of the displacement versus time? So displacement versus time is like displacement is equal to velocity multiplied by time, and the velocity is a constant. So this is going to be a straight line and the graph will be like this. So here you can just say that the displacement is equal to velocity into time, provided the velocity does not change. So the displacement is equal to s is equal to ut, and so this is the graph, which is a straight line. Now let us come to the uniformly accelerated motion. So here, now my graph is horizontal for the acceleration. What does it mean? It means that the acceleration is constant. Neither the magnitude nor the direction changes for the acceleration. So it is going like this. Okay, now, so if it is like this, how will be the velocity? Now, this is the horizontal line. So there is a straight line. So this graph will be a straight line graph now. Why? V is equal to u plus at, isn't it? So if u is 0, let us say, so v will be equal to at. Acceleration is constant, so the velocity graph will be a straight line passing through origin. Y is equal to mx. You might have done in maths AAHL. So this is this. Now, if you talk about the displacement now, so displacement will be 1 degree higher. It is going to be parabola. Clearly, s is equal to ut plus half at square. So if u is 0, so we can clearly say that it is going to be a quadratic equation and the graph will be parabolic. So the displacement versus a time graph in this kind of a motion for which the acceleration is constant will be a parabolic graph. Clearly, this is the graph there. So these are the 9 graphs in front of you. I think it should be easy for you to understand. You people can pause the video. You people can draw these graphs now. So I would be telling you further now. Now, how are these graphs related? Now, this is very, very important. So let us talk about one certain instant. Like, let us say we are considering this one certain instant here. So at the time t, the body is moving with an acceleration which is equal to a. No doubt about that. Now, this is the velocity with which it is moving now. And this is the particular displacement that we are now considering. So what is the relationship between these graphs now? So you can note this here, that first of all, the slope of st curve is this. So the slope of st curve here, what is the slope? Slope is like this. Yes, even this angle will be theta. Try to understand each and everything. Okay, now you are in IBDP 2, so you should be able to understand these things now. Okay, so this is theta and theta. So the slope of this, which is actually equal to tangent theta, that will be equal to the instantaneous value of the velocity. So this will be equal to v. Okay, So I repeat the slope here. So slope is generally written as m, like y is equal to mx plus c from maths. That is why I'm relating that. So this slope m is equal to tangent theta, mathematically speaking, isn't it? Now you can relate this thing with your maths, like maths AHL. So slope of ST curve is equal to velocity. What next now? So the slope of VT curve is equal to the acceleration. So the slope here, this theta, it is equal to the instantaneous acceleration here, that is A. Yes. So this is how they are related. What next now? Area. Area of AT curve. Now, earlier we were going down, like from ST curve, we were trying to find the value of V. From VT curve, we are trying to find the value of A. So we are going downwards. But now we are going upwards. So area of AT curve will give you velocity. This is the area that we are referring to. So area of AT curve will give you the velocity, instantaneous velocity, that is this value. And the area of VT curve, like this is a triangle, right angle triangle, half into base into height. So you find the area here. So we can say that area of VT curve is equal to the displacement S. Clear? Instantaneously it is equal to the displacement s. So this is the relationship between these three graphs, and you have to remember these three graphs. You would be getting a highly complex graph, like it will be a mixture of these three, and then they would be asking you like sometime the motion is like this, then it is increasing like this, then it will be like parabolic equation. You would be getting like a weird graph, I tell you, somewhere like this. And this is a ST graph. Accordingly, you have to create the graph of the velocity time graph, and you have to comment on that. These kind of questions you would be getting in the IB previous year questions. Okay, so you people can try that. And this is it for this lecture. The graphs are over, and I think the first part of which is like 2.1 is fairly like 50% is over now. The projectile motion is remaining, so we would be moving into the projectile motion in our next videos. So for today, like I think like for one day, these many videos are okay. So in the next video, we are going to talk about vertical projectile motion first of all. So if you are interested, you can move to the next video. Otherwise, you can stop here because this is enough for one day. Okay. So we would be completing our course not in a hurry. Some part will be have to be completed on a daily basis. Okay, so this is what you have to do accordingly. Okay, dear students, so all the best. Thanks for joining the YouTube channel. Please spread the message. Please tell your friends to join this and watch all the videos, so that will be beneficial for them also. It will be beneficial for both of us, for all of us. Okay then, dear students, all the best.